Okay. We were talking about integration by partial fractions, and we have done the case 1 where all the factors in the denominator were linear and they were non-repeated. So now let's come to the case 2 where all the factors are in the denominator are linear and some of them which may be repeated. Some of which are repeated. I have repeated my sentence because of the reason, because in possibly one of the factors may not be repeating. But if even some of the factors are repeating, we have to consider it as a case 2, in which to each linear factor, which is having r on the power, it means it's repeated. Ax plus b, which is linear, and in power x, which is repeated. Repeating r times, there will be corresponding the sum of r partial fractions as follows: a1 upon ax plus b plus a2 upon ax plus b power 2 plus and so on till ar power ax plus b power r. We will do that, where a1, a2, ar till ar are the constant. Let's do some questions and you will get the more clarity. Okay, we have to evaluate 2x plus 1 upon x plus 2 x minus 1 square. What I told you, this factor, these two are not repeated. But when we talk about x minus 1, which is in square, it means it is repeating. So we can see in denominator of the given integrand. In the exam, if you can write these statements, it gives an impact that you are understanding and why you are doing it. In denominator of the given integrand, the factor x plus 2 occurs exactly once and the factor x minus 1 occurs twice. It means it is repeated, right? So how can I write it? How in the partial fraction we will write? I told you, I explained it this way, right? So now I am writing it 2x plus 1 upon x plus 2 x minus 1 whole square. It would be a plus x plus 2 plus b upon x minus 1 plus c upon x minus 1 whole square. Getting my point? So, if I take LCM, this one, I think you are understanding, it's the way it was occurring once, so we have kept it once, and x minus 1 was in the twice, so we have taken it in B and C, and x minus 1 and then x minus 1 whole square. Now, both denominator are different. Okay, if I take the LCM, the way I have done in the previous questions, it would be x plus 2, x minus 1, x minus 1 whole square. It would be a, just give me a second. Okay, my phone was ringing. Right. A x minus 1 whole square plus b, it would be x plus 2 and x minus 1 plus c, it would be x plus 2. Is it clear? X plus 2, x minus 1 whole square. When you will see, these things will be curved. Or we can consider directly. Sorry, in the LCM, I have unnecessarily taken this part, which is not required. Right. Now it's right. Fine. Same. Otherwise, other things are the same. Now, we know 2x plus 1 equals to, it will be a x minus 1 whole square plus b x plus 2, x minus 1 plus c, x plus 2. Now, to find constant, we need to find constant a, b, and c. How we will find? Let us choose x equals to minus 2. Let's choose x equals to 1. And for convenience, we can say let's take x equals to 0 also. It would be easy because when something is in square, it would be easy for us for the convenience. If x is equals to minus 2, then 2 minus 2 plus 1 equals to, because 2x minus equals to a minus 3 square plus b. It would be minus 2 minus 2, it would be 0 plus c, it would be again 0. And we come out with minus 3 equals to 9a, which it times to be a equals to 1 upon 3 in negative. Is it clear? Then if we say x equals to 1, then we will say 2 plus 1 a is 0 plus b, it would be 1 plus 3, 0 plus c, 3. We can say c comes out to be 1. Is it clear? Now, if x equals to 0, then 2 plus, not 2, it is 0, then 0 plus 1 is 1 equals to a, it would be 1 minus power 3 plus b power 2 minus 1 plus c is 3. So simply put the values of x equals to 0. 2 minus 3 plus, sorry, 2 minus 3, 2 minus 1 and 2, right? Now, it comes out to be 1 equals to a minus 2b plus 2c. Now we know the values of a and b. We will substitute value of a and c as we have calculated above. So it would be easy for us to get the value of b. Equals to minus 1 upon 3 minus 2b plus 2 into 1 comes out to be, solve it, we will get b equals to 1 by 3. Now we get the values of all the three constants. So we can write it down. Question was 2x plus 1 upon x plus 2 and x minus 1 whole square. This was the question. See, 2x plus 1, x plus 2 minus 2. Now we are trying to put the values in this equation which we have framed by the partial fractions. Equals to minus 1 upon 3, a value is minus 1 upon 3, which is x plus 2. Now then plus 1 upon 3, 1 upon x minus 1 plus 1 upon x minus 1 whole cube. I think it's clear. It then is easy also. Then we have to integrate. Integration of it with respect to dx. Plus 1 x plus 2 x minus 1 whole square integration with respect to dx. It would be minus 1 upon 3 integration of with respect to dx plus 1 upon 3 integration 1 upon x minus 1 with respect to dx plus integration 1 upon x minus 1 cube. Not whole cube. I think I've done the I've done the mistake over here also. It is square. Sorry. It is square. It is square. I think it's clear now. This is also with respect to dx. Now simple integrated to the minus 1 upon 3. It would be log x plus 2 when something is like this plus 1 upon 3 which is log x minus 1. It would be plus when we know about it. We will consider it as the power minus 1, and when we will integrate now, I think it's a very easy one. Previously, we have done it, x minus 1 whole square 1 upon. It will not be considered as a log, but we will solve it in a simple way. It will be minus, sign will be coming out, and answer will be 1 minus 1. As in the previous questions, in the practice in the previous sessions, we have done it. How to integrate it is a simple one. Okay, take the power minus 2 and the plus 1 upon minus 1. Still, if you want, let me do it. 1 upon x minus, or I can write it in the way x minus plus 1 minus 2 dx. It would be x plus 1 minus 2 plus 1 upon minus 1. If we have to integrate it, we can integrate in this way, right? It would be plus c. It would be x plus 1 minus 1 upon minus 1. Right? We can write it minus 1 upon x plus or x minus, jo bhi tha. I think it was x minus, so we will keep it minus. Right? It will be x minus. And we have integrated in this way. I think it's clear. Now, let's proceed. It's x minus 1, and then we can write plus c. Okay. So answer comes out to 3. It can be log. If I take the common, it would be x minus 1 minus log x plus 2. I can write it because the minus sign like this, and 1 upon x minus 1 plus c. Can I say 1 upon 3 log x minus 1 upon x plus 2? Because now it's in a subtraction, and the property of the log is when we subtract it, it becomes like it. Minus 1 upon x minus 1 plus c. Is it clear? We can leave it here. And as this is your answer. Is it clear? Let's do one more question. Find 1 upon ex minus 1 power 2x. This sort of questions, whenever it comes, we can say e power x can equals to be t. Then dt equal upon dx. It would be e power x itself. So now when I solve it, or I can say so, dx equals to dt upon e power x. I can write 1 upon e power x minus 1 square dx as 1 upon e power x can be written as t minus 1 whole square. In place of dx, write dt upon e power x. Is it clear? And we know e power x is t. I can write it further. T minus 1 whole square dt upon t. Right? Now these two are the one that can come in the partial fraction form. This is a repetitive and it's a one. The way we have done the previous question, exactly the same. So I can say 1 upon t minus 1 whole square can be written as a upon t plus b upon t minus 1 plus c upon t minus 1 whole square. A plus bc. I think it's clear. I can write it down. Again, take the LCM. T and t minus 1 whole square. It would be a t minus 1 whole square plus t and t minus 1 plus c t, right? तो ये हमारा बन गया 1/t, t minus 1 whole square. Then we can write, again will be, things come up, 1 equals to a t minus 1 whole square. I'm telling you the steps. I'm doing the steps along. And please, I will suggest you also do the steps with me. Solve the question along with me. It would be easy. You will feel more confident. Now, we can get to solve the value of a, b, and c. We can keep t equals to 0, maybe t equals to 1, and t equals to minus 1. So if t is equals to 0 at the time, it would be 1 equals to a. T is 0 minus 1 whole square plus b 0 plus c 0. Over here, we will get a equals to 1. Is it clear? You also solve it and you will feel, if t equals to 1, in that case, sorry, it was 1. 1 equals to a 1 minus 1 whole square plus b 1 minus 1 plus c is 1. Can we solve it? We will get c equals to 1. I think it's clear. Now t equals to minus 1. We will keep it 1 equals to a minus 1 square plus b minus 1 minus 1 minus 1 plus c minus 1. We get it 1 equals to 4a plus 2b minus c. Now we will substitute. Values of a and c. 1 equals to 4 into 1 plus 2b minus 1. We get the value of b to be minus 1. I think it's clear. Now we get the values of a, b, and c. We can place it. Question was 1 upon, we will substitute the value of a, b, c in this equation. Right? So 1 upon t minus 1 whole square dx would be a upon 1 upon t. It would be minus b here. So 1 upon t minus 1 plus c is 1 upon t minus 1 whole square. Now, if we will integrate both the things, respect to dt. Sorry, this was dt. Now solve it. It will become log t log t minus 1 plus 1 upon it would be sorry, again the same way which we have done in the previous. Okay, it would be log minus t. It would become minus 1 upon t minus 1. I explained you in the previous question how to integrate it, how to integrate this. Okay, it would be minus sign will be outside and it will be and plus let it be small c, which is a step of integration. A question comes like this. It would be log, is minus sign, so t upon t minus 1 minus 1 upon t minus 1 plus c. And now we will substitute the value of t, which in the starting we have taken it. Therefore, our answer question would be, or we will say 1 upon e power x minus 1 whole square dot dx. It can be log e power x upon e power x minus 1 minus 1 upon e power x minus 1 plus c. So this is your answer. Easy? Right. Let's take a break again for 2 minutes and we will come back and we will discuss about the case